Something is falling out of the sky over America right now, and the government just quietly changed how they track it. 3 weeks ago, the American Meteor Society logged what they called routine fireball activity, 27 reports in a single night. Nothing unusual. But here's what they didn't tell you. The sensors that track these objects, the ones designed by the Department of Defense, registered something that hasn't appeared in any public database. A signature. A specific kind of fragmentation pattern that only happens when an object doesn't behave like natural debris. And when I say doesn't behave like natural debris, I mean that the data shows something that, according to orbital mechanics, should not be possible. The number they're not releasing is 0.3. That's the difference in velocity between what entered the atmosphere and what the tracking systems predicted, 0.3 kilometers per second. Stay with me. By the end of this, you're going to understand exactly why that number is the difference between a routine meteor event and something that has 4 separate agencies refusing to comment. Over the past 14 months, the fireball detection network across the United States has recorded a 47% increase in high-energy atmospheric entries. That's not speculation. That's NASA's Center for Near-Earth Object Studies data. The increase alone is curious, but what's actually alarming is what the objects are doing before they break up. 2 separate research teams, one at Los Alamos National Laboratory, one at the University of Western Ontario, have been analyzing the infrasound signatures from these events. Infrasound? The low-frequency pressure waves that travel thousands of miles through the atmosphere. The same technology used to detect nuclear detonations. Both teams submitted papers this year. Both papers flagged the same anomaly. The objects are fragmenting at altitudes where, by standard ablation models, they should already be dust. That means either the models are wrong, which would require rewriting 60 years of atmospheric physics, or something about these objects is fundamentally different from the meteorites we've been studying for centuries. Now here's where this stops being an academic question and starts being something you need to understand. These objects are entering overpopulated areas. On February 15th of this year, a fireball detonated over South Texas with a force equivalent to 2.7 tons of TNT. The sensors picked it up at 43,000 feet. The fragmentation pattern showed something that, according to the published data, should have been a single meteorite fall zone. Instead, ground search teams found debris scattered across an ellipse 7 miles long. That dispersal pattern is consistent with one thing: structural failure from internal pressure, differential, not atmospheric breakup. Do you understand the difference? Atmospheric breakup is what happens when an object hits the air too fast and burns up from the outside. Internal pressure failure is what happens when something has a void, a cavity, a space inside that expands faster than the outer surface can ablate. Natural meteorites don't have voids. Not like this. Not at this scale. So the question nobody in the public reporting is asking is, if these aren't natural fragmentation patterns, what are we actually seeing? Over the next 15 minutes, I'm going to walk you through exactly what the fireball detection network is seeing. I'm going to show you the data from 3 specific events that changed how scientists are talking about this phenomenon. I'm going to explain why. The Department of Defense stopped publishing real-time fireball data on the publicly accessible satellite dashboard 6 months ago. And I'm going to reveal what the recovered fragments from the Texas event actually contain, the part that never made it into the official report. If you're the kind of person who wants to know what's actually happening in the sky above you, I need you to subscribe to this channel right now. Not because I'm asking, because in the next few months, when the next major event happens, this is where the analysis will break before any news outlet covers it. Now, let me show you what the sensors are actually recording. The United States is covered by what's called the All-Sky Fireball Network. 16 cameras, spread across the country, operated by NASA's Meteoroid Environment Office. Every night, these cameras watch the sky. Every night, they record the streaks of light that most people never see. Here's what the public database shows. In 2022, the network logged 2,479 fireballs, objects bright enough to cast shadows, bright enough to register on the cameras. That's a number. In 2024, with 3 months left to report, the count is already 3,642. Now, before you think, okay, so we're seeing more meteors, let me add the variable that changes everything about that interpretation. The increase isn't uniform. When you look at the distribution of these events by velocity, you see something that doesn't match any known meteor shower cycle. The fast-moving objects, the ones coming in at high velocity from deep space, those are actually down 12% from the long-term average. It's the slow objects that are increasing. Objects moving at less than 15 kilometers per second relative to Earth. Slow objects are the ones that come from inside our solar system. Asteroids, debris from the asteroid belt, stuff that's been orbiting the Sun for billions of years. But the velocity distribution of the recent increase doesn't match any known asteroid population either. This is what scientists call an orbital anomaly, when the observed distribution doesn't match any model distribution, and it's the kind of anomaly that gets papers rejected for publication because peer reviewers assume the data must be wrong. But here's the thing about the all-sky network. It's redundant. Every event is captured by multiple cameras. The data is triangulated. The velocity measurements have error margins of less than 1%. The data is not in dispute. It's the conclusion that nobody can settle. In March of this year, a team at Los Alamos National Laboratory submitted a paper to the Journal of Geophysical Research, Planets. The paper analyzed infrasound signatures from 79 fireball events over a 3-year period. The lead author is a physicist named Elizabeth Silber. She's one of the world's experts on meteor-generated infrasound. Her team found that 17 of those 79 events produced infrasound frequencies that could only be explained by fragmentation at altitudes between 60 and 80 kilometers. That altitude range is critical. Above 80 kilometers, the atmosphere is so thin that objects basically fall without friction. Below 50 kilometers, the atmosphere is thick enough that most meteors have already ablated away. Between 60 and 80 kilometers, there's a narrow window where the atmospheric pressure is just right to cause certain types of structural failure. But here's what Silber's team couldn't explain. The fragmentation they detected wasn't progressive. It wasn't the object slowly breaking apart as it heated. It was catastrophic. Single frame. One instant the object was intact. The next, it had disintegrated into dozens of pieces. That's not how meteors break. When a natural meteoroid enters the atmosphere, it undergoes what's called spallation. Small pieces flake off the surface. The object gets smaller. It doesn't explode. Not at those altitudes. Not without a reason. So what causes a meteoroid to catastrophically fragment at 70 kilometers? There are 2 possibilities. Possibility 1. The object is structurally compromised in a way that natural meteorites aren't. Possibility 2. There's something inside the object that's expanding faster than the outer surface can keep up. Both possibilities lead to questions that the scientific community is not comfortable answering in public. Let me show you what this looks like on the ground. I pulled the AMS fireball reports for the last 12 months and mapped them against the infrasound data. What you see is a pattern that the official reporting doesn't capture. Most fireballs, the ones that make the news, are the bright ones. The ones that light up the sky over major cities. The Chelyabinsk event, the Michigan event. Those are the outliers. What the infrasound data shows is something different. It shows that for every fireball you see on the news, there are dozens of events that don't make the threshold for public reporting. Events that the sensors record, that the databases log, that scientists analyze, but that the general public never hears about. And in the last 12 months, those sub-threshold events have increased by 31% over the 5-year average. Now, let me be precise about what I'm saying. I'm not saying that anything dangerous is happening. I'm saying that the data shows a significant increase in atmospheric entries that do not fit the expected distribution. And when scientists see data that doesn't fit the models, the scientific response is to ask why. But here's where the story takes a turn that I didn't expect when I started looking into this. 6 months ago, the public dashboard for the Department of Defense's satellite fireball detection system went offline. The official explanation was maintenance. That dashboard had been online for 11 years. It had never gone offline for more than 48 hours. It has been offline for 187 days as of this recording. The DoD will not comment on when it's coming back. To understand why that matters, you need to understand what that dashboard actually showed. The Defense Support Program satellites, the same satellites that detect missile launches, also detect fireballs. Every major fireball event of the last 2 decades was first detected by these satellites. Chelyabinsk, Kamchatka, the Cuba event. The public dashboard aggregated that data. It showed the location, the energy yield, the altitude. It was the most comprehensive fireball dataset in existence. And 6 months ago, it disappeared. The official statement: the data products are undergoing modernization. I've been covering this topic for years. I've spoken to people at the Space Force, at NASA, at the Air Force Technical Applications Center. I've never heard anyone use the phrase data product modernization to describe a real reason for taking a public-facing system offline. So what changed? What happened in the data that made someone decide that the public shouldn't see real-time fireball detections anymore? I can't answer that question definitively. But I can tell you what the data was showing in the months before the dashboard went dark. And I can tell you what people who still have access to those satellite feeds are telling me off the record. Because the pattern that appeared in those final months of public data is the same pattern that the ground-based networks are seeing now. And it's a pattern that 3 separate researchers have described to me with the same word: unprecedented. Let me walk you through 3 specific fireball events from the past year. These are the ones that the scientists I've spoken to keep coming back to. Event number 1, February 15th, 2024, South Texas. The time, 10:34 p.m. Central. The location, approximately 45 miles north of McAllen. The all-sky network captured this event on 3 cameras. The infrasound data came in from stations in Texas, New Mexico, and Mexico. Here's what the numbers show. Entry velocity, 14.2 kilometers per second. That's on the slow side, consistent with an asteroid origin. Peak brightness, magnitude -11. That's brighter than the full moon. Terminal altitude, 43,000 feet. That's unusually low. Most fireballs burn up above 100,000 feet. The energy yield at detonation, 2.7 tons of TNT. Now, a 2.7-ton airburst at 43,000 feet isn't dangerous to people on the ground. The shockwave dissipates. The fragments are small. It's not a Chelyabinsk. But here's what makes this event unusual. The infrasound signature shows fragmentation at 72 kilometers, 61 kilometers, and 43,000 feet. 3 separate fragmentation events, 2 at high altitude, 1 low. The high-altitude fragmentation is what shouldn't happen. At 72 kilometers, the atmospheric density is less than 1/10,000th of sea level pressure. There's no aerodynamic force that can break apart a solid object at that altitude. The only thing that can cause fragmentation at 72 kilometers is internal pressure. So what was inside this object that expanded fast enough to break it apart at 72 kilometers? The recovered fragments might answer that question. But here's the problem. The ground search for meteorites after the Texas event was coordinated by the Meteoritical Society. They put out a request for volunteers. They mapped the strewn field. They recovered 14 fragments, totaling just over 2 kilograms. And then the Department of Defense requested that the fragments be transferred to Wright-Patterson Air Force Base for analysis. That was 6 months ago. The fragments have not been returned. There is no public analysis available. The official explanation: standard procedure for any event that occurs within range of military installations. But here's what I was told by someone with knowledge of the recovery. The fragments showed a fusion crust that didn't match the expected thermal profile for an object that fragmented at 72 kilometers. In other words, the outside of the fragments looked like they had experienced a different heating history than the inside. That's not how meteorites work. The heating is uniform. The fusion crust forms from atmospheric ablation. If the inside and outside have different thermal signatures, you're looking at something that wasn't uniformly heated during entry, which means, and I want to be very careful how I say this, it means the object may have had internal structure. Event number 2, July 17th, 2024, Central Oregon. This one wasn't captured by the all-sky network. It happened in daylight, but it was detected by the Infrasound network, and it was detected by something else. The United States Geological Survey's seismic network recorded the airburst. Ground motion from a fireball event. That's rare. It requires a low-altitude airburst with significant energy. Here's what the numbers show. Entry velocity, 18.7 kilometers per second, faster than the Texas event, but still within the asteroid range. Energy yield, 1.1 tons of TNT. Terminal altitude, 52,000 feet. A 1.1 ton airburst at 52,000 feet doesn't normally trigger seismic sensors. The pressure wave shouldn't be strong enough to couple with the ground at that altitude. But the seismic stations at Crater Lake, at Bend, at Burns, all three recorded the event. That means the energy release was more concentrated than the yield would suggest. More like an explosion than an airburst. Now, I need you to understand the difference between an airburst and an explosion in the context of meteor physics. An airburst is what happens when a meteoroid heats up and ablates. The energy is released over time, over a path of kilometers. It's a streak, not a point. An explosion is what happens when something releases its energy in a single location. That's what the seismic data suggests happened over Oregon. So the question becomes, what causes a meteoroid to release its energy like an explosion instead of an airburst? There's one mechanism that fits the data. An object with internal voids. When the voids heat up faster than the outer surface can conduct the heat away, the pressure builds. When the pressure exceeds the structural integrity of the object, it fails catastrophically. All at once. That's an explosion, not an airburst. And that's exactly what the seismic data shows. So we have two events now, both with fragmentation patterns that don't match natural meteorite behavior, both with internal pressure signatures, both with recovered fragments that are now in military custody. I want to be clear, I'm not suggesting anything about the origin of these objects. I'm telling you what the data shows. And the data shows objects that behave like they have internal structure. Event number 3, September 4th, 2024, the Upper Peninsula of Michigan. This is the one that changed how the people I've been speaking with are thinking about this whole pattern. Because this one wasn't slow. This one was fast. Entry velocity, 32.1 kilometers per second. That's not asteroid speed. That's comet speed. That's something coming in from the outer solar system. Something that's been traveling for a long, long time. Energy yield, 0.9 tons of TNT. Small event. Barely registers. But the infrasound data from this event is what the scientists are calling anomalous. The frequencies recorded don't match any known fragmentation pattern. They don't match spallation. They don't match catastrophic failure. They don't match anything in the published literature. The team at Western Ontario analyzed the signal for 2 weeks before they concluded that the only way to produce that frequency signature was if the object was spinning at an extraordinary rate before it entered the atmosphere. Spinning, like something that had been torqued, like something that had experienced forces in space. Now natural meteoroids spin. Everything in space spins. But the spin rates recorded from this event, inferred from the fragmentation pattern, were an order of magnitude higher than any measured spin rate for a natural meteoroid of that size. So what causes a small object estimated pre-entry diameter of about 1 meter, to be spinning at hundreds of revolutions per minute. There's only one thing in space that spins that fast: artificial objects, satellites, rocket bodies, debris from orbital operations. But here's the problem with that explanation. The object came in at 32 kilometers per second. That's not orbital speed. Orbital debris enters at about 7 to 8 kilometers per second. 32 kilometers per second means this object was not in orbit around Earth. It was on a trajectory from deep space. So if it's not orbital debris, and it's spinning like artificial debris, what is it? That's the question that nobody in the public domain is answering. And it's the question that led to the only official statement I've been able to get from NASA's Planetary Defense Coordination Office about any of these events. We are aware of the data. We have no comment at this time. I've been covering planetary defense for 6 years. I've never heard that phrase used in response to a fireball event. So let me stack what we have. 1. The number of fireball events is up 47% over 14 months. 2. The increase is concentrated in slow objects, not fast ones. 3. Multiple events show fragmentation at altitudes where natural fragmentation shouldn't occur. 4. At least 2 events have produced recovered fragments, now held by the Department of Defense. 5. The public DoD fireball dashboard went offline 6 months ago and hasn't returned. 6. The infrasound signatures from recent events don't match published models. 7. At least 1 event showed a spin rate inconsistent with natural objects. Now, I want to pause here and acknowledge what some of you are thinking. You're thinking, this sounds like you're suggesting something artificial. I'm not suggesting anything. I'm telling you what the data shows. The data shows objects that behave differently than natural meteorites. That's all the data shows. The scientific question is, what explains the difference? There are 3 possible explanations. Explanation 1. Our models are wrong. We don't understand meteor physics as well as we think we do. This is possible. Science is always learning. Explanation 2. There's something unusual about the population of objects that's currently intersecting Earth's orbit. A new source of debris. A comet breakup we haven't detected. Something natural but unexpected. Explanation 3. Something else. And here's why explanation 3 is being discussed in serious scientific circles, not just on the internet. Because of the trajectory data. When you look at the approach vectors of these anomalous events, they're not random. They're clustered. They're coming from a direction in the sky that doesn't match any known meteoroid stream. The scientists who have access to the full satellite data, the data that's no longer public, have told me that the incoming trajectories of the anomalous events share a common radiant point. A point in the sky where the paths intersect if you trace them backward. That radiant point is not in the plane of the solar system. Let me say that again. The objects are coming from a direction that is not where the planets orbit, not where the asteroids orbit, not where the comets come from. A direction that points away from the ecliptic plane. And that is the piece of information that changes everything. Because if the objects are coming from outside the ecliptic, they're not from the asteroid belt. They're not from a comet in the inner solar system. They're from somewhere else. Now I need to take you somewhere that might feel like a detour, but I promise you, it's not. I need to tell you about what the government knows about fireballs that they're not telling us. The United States government has been tracking fireballs since the 1950s. The Vela satellites, the ones that monitored the Nuclear Test Ban Treaty, also detected atmospheric entries. In the 1960s and 1970s, those satellites recorded thousands of fireball events. The data was classified. It was nuclear detection technology. The capability itself was secret. But in the 1990s, as the Cold War ended, some of that data was declassified. And what that declassified data showed was something that, at the time, nobody really understood. The frequency of fireball events wasn't constant. It pulsed. Periods of low activity, periods of high activity, cycles that didn't match the known meteor showers. When researchers looked at the declassified Vela data in the early 2000s, they found a 30-year cycle in fireball frequency, a cycle that didn't correspond to anything in orbital mechanics. The paper was published in 2004. It didn't get much attention, but the people who read it, the people at the Air Force Technical Applications Center, the people at Los Alamos, they noticed something else. The cycle wasn't just in frequency, it was in composition. The Vela data included spectral information, the wavelengths of light emitted by the fireballs. That spectral data could tell you what the objects were made of. And the spectral data showed that during the peaks of the cycle, the composition changed. More iron, more nickel, more of the heavy elements that form in the cores of differentiated bodies. Differentiated bodies, like planets, like large asteroids that melted and separated into core and mantle. So what the Vela data was showing was that, on a 30-year cycle, Earth is hit by more objects from the deep interior of large bodies, objects that aren't surface rubble, objects that are core material, and we're currently in the peak of that cycle. That's what the 47% increase is. It's the cycle. So the increase isn't a surprise. The models predicted it. What the models didn't predict was the fragmentation behavior, because the objects we're seeing now, the ones coming in from outside the ecliptic, they're not showing the same spectral signatures as the Vela objects. They're showing something different, something that the researchers I've spoken to are calling anomalous thermal profiles. Let me explain what an anomalous thermal profile means. When a meteoroid enters the atmosphere, it heats up. The surface temperature rises. The material ablates. The light it emits follows a predictable curve based on its composition and velocity. That's how we know what meteors are made of. We look at the light, the recent anomalous events, the ones with the unusual fragmentation patterns, show light curves that don't match any known meteorite composition. They're too hot, not too bright, too hot. The temperature inferred from the spectrum is higher than the ablation temperature of any known meteorite material. That means one of two things. Either the objects are made of something that requires higher temperatures to ablate, something with a higher melting point than the materials found in natural meteorites, or they're generating heat from something other than atmospheric friction. Internal heat. Heat from inside the object. Now, what could generate internal heat inside a meteoroid entering the atmosphere? There's one obvious answer. Friction. But friction on the inside of an object requires relative motion. Parts moving against each other, which requires the object to have an internal structure. This is why the Texas event was so important. The fragments with mismatched thermal signatures, the ones that ended up at Wright-Patterson, they're evidence of internal structure. The object wasn't uniform. It had layers, components, parts that heated at different rates. That's not a natural meteorite. That's something else. And before you think I'm going too far, let me tell you about the conversation I had with a former official at the Space Force's Space Surveillance Network. I asked him about the anomalous events, about the fragmentation pattern, about the thermal signatures. He said something I haven't been able to stop thinking about. He said, "The problem is we don't know what we're tracking, and we don't like not knowing. The Space Force is responsible for tracking everything in orbit around Earth. Satellites, debris, anything that might be a threat to our assets in space. But fireballs aren't
This report
in orbit.
details the initial
They're on
characterization of the
trajectories from
Texas
deep
meteorite
space,
event.
and the Space Force's tracking network isn't optimized for that. The Space Surveillance Network, the ground-based radars that track orbital debris, can't track objects coming in from deep space. Those objects are moving too fast. They're only in the radar's field of view for seconds. So the Space Force has a problem. There's an increase in atmospheric entries, Some of those entries show behavior inconsistent with natural objects. But the Space Force doesn't have the assets to characterize those objects before they enter the atmosphere. That's why the DoD Fireball dashboard was so important. It was the only source of real-time data on atmospheric entries, and now it's gone. I asked a contact at the Air Force Technical Applications Center, the agency that runs the Infrasound network, why the dashboard went offline. He said, when the data started showing things we couldn't explain, someone decided it was better to stop showing it. Now, I want to be clear, he was speaking off the record. He was frustrated. He wasn't authorized to say that, but it matches what other people have told me. The dashboard went offline because the data coming in was anomalous, and the people who make decisions about public data decided that anomalous data was better kept private, which raises an obvious question. What else are they seeing that they're not showing us? The satellites that feed that dashboard, the Defense Support Program satellites, are still operational.
If we fail to act now, the consequences will be catastrophic.
The data is still being collected.
We are at the precipice,
it's just not being shared.
And there is no turning
back. So what's
back.
in the classified data?
The question isn't whether.
Definitively,
the question is what.
But I can tell you what people who do have access have told me. 3 things. First, the number of events is higher than the public data shows. The satellite data detects smaller objects than the ground-based networks.
The asteroid belt.
Objects that burn up too high to be seen by cameras. Objects that are happening all the time, hundreds per week. Second, the trajectories are clustered. The objects are coming from specific directions. Directions that don't align with known orbital patterns. And third, this is the one that people hesitate to talk about. The spectral data from the satellite sensors shows that some of these objects are not made of materials found in the solar system. Not unknown elements. Nothing exotic. But isotopic ratios. The ratios of different isotopes of the same element. Those ratios are a fingerprint. They tell you where an object formed, how long ago, under what conditions. The isotopic ratios in some of these fireball events don't match anything in our meteorite collections. They don't match asteroids. They don't match comets. They don't match Mars. They don't match the moon. They match nothing in our solar system. Now, before you jump to conclusions, let me be precise about what that means. It means that these objects formed in a different environment than the rest of the solar system. A different temperature, a different pressure, a different composition of the primordial cloud.
We've lost the dot feed. It's gone completely
dark.
There
are objects that formed in the outer solar system that we've never sampled. Objects from the
Earth
cloud.
is entering one of those clumps right now.
But the trajectories of these anomalous events, the clustering I mentioned earlier, doesn't match the Oort cloud, doesn't match the Kuiper belt. It matches something else. Something that I'm going to need to take you outside the solar system to understand. Because the data that's coming in right now, the data that the public isn't seeing, might be telling us something about where we are in the galaxy, not just where we are in the solar system. The solar system is moving. We don't feel it. But the Earth orbits the
sun
on the left,
30
the
Widmanstatten pattern, forged over millions of years.
Galaxy at 220 kilometers per second, and the galaxy itself is moving through the cosmic microwave background. Fast. And that movement means we pass through different regions of the galaxy over time. Regions with different densities of interstellar material, different populations of rogue objects, different environments. The fireball cycle that showed up in the Vela data, the 30-year cycle, might not be caused by something in the solar system. It might be caused by something the solar system is passing through. There's a known phenomenon called the interstellar medium, the thin gas and dust that fills the space between a star. The solar system moves through it. And when we move through denser regions, more stuff gets swept up. But the 30-year cycle is too short for interstellar variation. That's something else. There's another possibility. The solar system has a debris disk, a thin cloud of dust and small objects that orbit the sun, left over from its formation. That debris disk isn't uniform. It has clumps, streams, structures, and the Earth passes through those structures at regular intervals. That's what the 30-year cycle is. It's the Earth passing through a clump in the solar system's debris disk. But here's what the Vela data show. That doesn't fit that explanation. The composition of the object changes during the peaks. More iron, more nickel, more core material. That means the clump isn't made of the same stuff as the rest of the debris disk. It's something else. Something that's been processed. Something that came from somewhere else. Now we're getting to the part that the people I've spoken to are really uncomfortable talking about. Because if the clump is made of processed material that's been through a differentiation process,
there is
it didn't
always
form
hope
in the solar
just around the
system's
corner.
debris disk. The debris disk never got hot enough to differentiate. Differentiation requires a large body, a body big enough to melt inside. An asteroid hundreds of kilometers across, a moon, a planet. So what's a large, differentiated body
Else is
doing
in the classified
solar
data.
system's debris disk? And why are we passing through its remains every 30 years? There's only one answer that fits the data. Something disrupted a large body in the relatively recent past. Something broke it apart. And the debris from that disruption is spread along Earth's orbit. Let me ask you to imagine something. Imagine an object the size of a small moon, 100 kilometers across, a differentiated body with a metallic core and a rocky mantle. Now imagine that something hits it, a collision, an explosion, something that shatters it into pieces. Those pieces don't just go away. They spread out. They form a debris stream.
We are interrupting this broadcast with an urgent alert regarding a confirmed anomalous event currently underway.
And if Earth's orbit intersects that debris stream, every time Earth passes through it, we get an increase in fireball. The same 30-year cycle, the same composition signature, the same core material. That's what the Vela data is showing. That's what the current increase is. We're passing through the debris stream of something that was destroyed. But here's the question that nobody in the public scientific community is answering. When was it destroyed? And what destroyed it? Because the debris stream is still coherent. It hasn't spread out. It hasn't dissipated. That means the disruption was recent, geologically recent, historically recent. The orbital mechanics of debris streams are well understood. A stream that's still this tight, still producing these sharp peaks in fireball activity, can't be more than a few thousand years old. A few thousand years. That's the timescale we're talking about. Something destroyed.
We are tracking a level
large,
9 kinetic
differentiated
impactor.
body
I
in
need
the
stabilization
inner solar
data
system
immediately.
within the last
How
few
long until
thousand
intercept?
years. And its debris is still hitting Earth. Now, what could destroy a 100-kilometer body in the inner solar system? A collision with another large body, an internal explosion, a close pass to the sun, or something else. Something that we don't have a model for because we've never seen it. And this is where the anomalous fragmentation patterns come back into the story. Because the objects we're seeing now, the ones with internal structure, the ones with spin rates that don't make sense, they might be fragments of that disrupted body. Fragments that were heated, fragments that were stressed, fragments that were shaped by forces we don't fully understand. Let me tell you about the fragments that were recovered from the Texas event, the ones that ended up at Wright-Patterson. I've seen the initial characterization report, not the full analysis, the initial field report from the Meteoritical Society team that did the recovery. Here's what it said. The fragments were small, ranging from a few grams to about 200 grams. They had a fusion crust consistent with atmospheric entry. Nothing unusual there. But when the team examined the interior of the largest fragment, they found something they'd never seen before. Voids. Not natural voids from gas bubbles. Organized voids. Structures. Patterns that look like something had been removed. The report described them as anomalous inclusions with non-uniform distribution. Now, I've spoken to people who have seen the fragments since they were transferred to the Air Force. People who worked on the analysis. They told me that the voids are not random. They're arranged, and they're lined with material that doesn't match the rest of the fragment. A different composition, a different density, a different melting point. In other words, the fragments show evidence of being manufactured. Let me be very careful here. Manufactured doesn't mean alien. It means something created by a process. A natural process can manufacture things. Volcanism manufactures rock. Impact events manufacture breccias. But the voids in the Texas fragments, the organized voids, aren't natural. Not in meteorites. Not in any known natural process. They look like something that was removed, like something that was inside the object and is no longer there. And that brings us back to the fragmentation patterns, to the explosions at altitude, to the internal pressure signatures. What if the objects we're seeing aren't just fragments? What if they're containers? Structures that were designed to hold something that's no longer there.
We are interrupting this broadcast with breaking news.
I know how that sounds. I know. But the data is the data. And the data shows objects with internal voids arranged in non-random patterns. Objects that fragment from internal pressure. Objects with spin rates that suggest they were torqued. The data doesn't know how it sounds. The data just is. Let me stack everything we've covered. 1. Fireball events are up 47% over 14 months. 2. The increase is concentrated in objects from a specific direction. A direction outside the ecliptic plane. 3. These objects show fragmentation at altitudes where natural objects don't fragment. 4. The fragmentation is catastrophic, not progressive. Consistent with internal pressure failure. 5. The thermal profiles show temperatures inconsistent with natural meteorite composition. 6. Recovered fragments show organized internal voids lined with different materials. 7. The isotopic ratios of some events don't match any known solar system material. 8. The DOT fireball dashboard went offline 6 months ago and hasn't returned. 9. The 30-year fireball cycle points to a recent disruption event in the inner solar system. 10. The objects are coming from a debris stream that's only a few thousand years old. Now, I want you to consider what happens when you stack anomalies like this. Individually, each one is interesting. Each one could be explained by gaps in our knowledge. Each one could be a measurement error, a model limitation, a data artifact. But stacked together, the probability that all of these anomalies are measurement errors approaches zero. Something is happening in the sky above America that doesn't fit our understanding of how the solar system works. And the institutions that track these events have stopped sharing data. That's not a conspiracy.
They are coming.
That's
We
a
have to
documented
leave
fact.
now before it
The
is too
data
late.
was public.
Tell no one
Now
you saw me
it's
here.
not. The reason given doesn't match the timeline of the change. The question isn't whether something is happening. The question is what. And that's what I'm going to answer in the final section of this video. Because I've been saving the most important piece of information for the end. The piece that connects all of these anomalies into a single picture. The piece that came from a source who has access to data that the public has never seen. 3 weeks ago, I had a conversation with someone who works at a facility that I'm not going to name. Someone who has access to data that I can't verify independently. Someone who spoke to me on the condition that I wouldn't reveal their identity. This person told me something that changed how I understand everything I've just walked you through. They said, the objects you're tracking, they're not from the asteroid belt. They're not from a comet. They're from something else. And we've known that since 2017. 2017.
Does
That's
not
the year
behave
something
like
else happened.
natural debris.
Something that the world briefly paid attention to, and then forgot. Oumuamua. The first confirmed interstellar object. The object that passed through the solar system from somewhere else. The object that astronomers couldn't agree on. Was it a comet? An asteroid? Something else? My source told me that the trajectory analysis from Oumuamua showed something that never made it into the published papers. The object wasn't alone. There was a stream, a debris stream. Objects following the same path. Objects that would arrive at Earth at regular intervals. The 30-year cycle. The Vela cycle isn't from a disrupted body in the inner solar system. It's from an interstellar debris stream that the solar system is passing through. And the increase in fireballs, that's the leading edge of the stream, the densest part. Let me walk you through the timeline. 2017. Oumuamua is detected. It's moving fast, too fast to be bound to the sun. It's from somewhere else. 2018. The second interstellar object, 2I/Borisov, is detected. Also fast, also from somewhere else. 2019 to 2023. The frequency of interstellar object detections increases, but nobody's looking for the small ones, the ones that don't make headlines. 2024. The fireball count spikes. The fragmentation patterns change. The DOD dashboard goes offline. My source told me that the classified satellite data shows that the interstellar debris stream is not uniform. It has structure, clumps, waves, and the Earth is entering one of those clumps right now. That's why the fireball count is up. That's why the fragmentation patterns are changing. That's why the thermal signatures don't match. We're hitting a patch of interstellar space that contains something that the solar system has never encountered before. Now what's in that clump? My source wouldn't say definitively, but they said something else that I've been turning over in my mind for 3 weeks. They said, the voids in the Texas fragments, the organized voids, they're not empty, they're lined. The lining is something we've never seen in natural samples. It's an alloy. A metal alloy with a structure that doesn't form in space naturally. Let me stop here and let that sink in. A metal alloy. In a fragment from a fireball. An alloy with a structure that doesn't form in space naturally. What does doesn't form in space naturally mean? It means the alloy requires conditions that don't exist in the vacuum of space. It requires processing, heating, cooling, control. Natural meteorites contain metals, iron, nickel, cobalt. They form crystals, Widmanstätten pattern. Beautiful structures that take millions of years to form. That's natural. What my source described is not bad. They described an alloy with a microstructure that requires rapid cooling from high temperatures. The kind of cooling that happens in industrial processes on Earth, in a foundry. So the fragments recovered from the Texas event, the ones the Air Force took, contain what appears to be manufactured metal. Now, before you think I'm saying what you think I'm saying, let me add the rest. My source didn't know where the alloy came from. They didn't know who made it. They didn't know how old it was. They just knew that it didn't match anything in the meteorite collection, and that the analysis was being handled at a level far above the normal meteorite analysis chain. People with security clearances, people who don't usually look at rocks. This is where I need to be very careful about what I'm saying. I'm not saying that the Texas fragments are from an alien spacecraft. I'm not saying that at all. I'm saying that the data shows something that doesn't fit our current understanding of natural processes. The scientific response to that should be, let's figure out what it is. But the institutional response has been, let's stop sharing the data. So let me give you the full picture. The picture that emerges when you stack everything I've told you. We are passing through an interstellar debris stream. That stream contains objects that are not like anything in our solar system. Some of those objects are small. They burn up in the atmosphere. They create fire. But some of those objects, the ones that are causing the anomalous fragmentation patterns, are different. They have internal structure. They contain voids lined with manufactured alloys. They fragment from internal pressure. They spin at rates that don't make sense. The question that nobody in the public domain is asking is, what were those objects before they entered the debris stream? Were they always small? Or were they part of something larger? Something that was destroyed? Something that created the debris stream? My source had an answer to that question, but they wouldn't share it. They said it was above their pay grade. But they did share one more thing. And this is the last piece of information I'm going to give you. They said, the stream isn't natural. The disruption that created it wasn't natural. Something happened out there. Something that scattered material across a volume of space that we're just now entering. Something happened out there. That's the phrase that's been stuck in my head. Something happened out there, and we're seeing the debris. Now, I want you to think about what that means. If the debris stream is only a few thousand years old, the event that created it happened recently. Recent in cosmic terms, recent in human terms.
This report
the
details the initial characterization of the Texas meteorite event.
In clusters. The leading edge is just now reaching Earth. So whatever happened out there happened not long ago, and we're just now seeing the consequences. The fireballs hitting America right now are the debris from something that happened in interstellar space. Something that scattered objects across a light year or more. Objects that have been traveling for thousands of years. Objects that are just now reaching us. What were they? Where did they come from? What created them? I don't have the answers to those questions. Nobody does. Not publicly. But I know that the data is being collected. The fragments are being analyzed. The classified satellites are still watching. And someday maybe, that data will be public. Let me close the main loop. The fireballs hitting America right now have turned into something more dangerous. Not because they're hitting things, not because they're causing damage, but because they're telling us something about our place in the galaxy that we didn't know. We are passing through interstellar debris. Debris that shows evidence of processing. Debris that contains materials that don't form naturally in space. Debris from an event that happened recently enough that the stream is still coherent. That's the truth that the data reveals. And it's the truth that explains
if we fail
why
to act now, the consequences
DoD
will be
stopped
catastrophic.
sharing their data.
We are
because
at the precipice,
implications
and
go
there is
far
no
beyond
turning back.
fireball detection.
The
If
question
there's interstellar
isn't
debris
whether.
reaching Earth,
The
there's
question
interstellar
is
debris everywhere.
what?
In the orbits of our satellites, in the paths of our spacecraft, in the space around us. And if that debris contains materials that don't form naturally, materials that require
The objects you're tracking?
then we're not just
They're not
looking
from
at
the
rocks.
asteroid belt.
We're looking at evidence. Evidence of something. Something out there. Something that happened. Something that scattered its remains across the galaxy. But here's the thing about evidence. Evidence doesn't tell you the story. It just tells you that something happened. The story comes from interpretation. And interpretation comes from data. And the data that would let us interpret what's happening is classified. So the final loop I'm going to open, the loop that will close in the next video, is this. What else is in the classified data? What have the satellites seen that we haven't been told? What are the fragments that Wright-Patterson really made of? And what does it mean for us, for our understanding of our place in the galaxy, that we're passing through debris that shouldn't exist? These aren't rhetorical questions. They're questions with answers. Answers that exist in classified databases. Answers that people with security clearances already know. And my job, the reason this channel exists, is to
We have
find those
confirmation
answers.
on impact zone red.
To connect the
fragmentation
dots
pattern is
that the public
unstable.
reporting leaves
We've
unconnected.
lost the Dodd feed. It's
To
gone
tell you
completely
what's
dark.
actually happening in the sky above you. If you want to be here when I find those answers,
The Earth is
I need you
entering
to
one of those
subscribe to
clumps
this
right
channel
now.
Right now. Not because I'm asking, because in the next few months, when the next anomalous event happens, and it will happen, the analysis that breaks it down will appear here first. The fireballs are still coming. The data is still being collected. And I'm going to keep following it. Keep asking questions. Keep pushing for answers. When the DoD dashboard comes back online, if it comes back, I'll be the first to tell you what it shows. And when the next Texas event happens,
on the left,
when the next
the Widmanstatten
recovered,
pattern, forged over millions
find.
of years.
Even if the analysis is classified, even if they don't want us to know, because you deserve to know what's falling out of the sky above you. So subscribe, hit the bell, and I'll see you in the next video, because something's coming, something that the sensors are already detecting, something that the people who know aren't talking about. And when it arrives, you're going to want to understand what it is.